Okay, hello and welcome. It is the 6th of June, 2020, here in sunny Toronto, and we're going to be focusing on today on this serendipitous Saturday. We'll be focusing on the object-oriented programming fundamentals of JavaScript. See how much we can cover today, but that's kind of been the topic that's come out of the group organically. So let's go ahead and jump into that today. I have no idea how to plan this. Just gonna kind of go off top of my head. So if anyone has any questions or anything, please jump in. So I'm going to open up VS Code. You guys can all see my screen? Oh, no, you can't because I'm not sharing. There we go. All right. You guys can see it now?
Okay, we see it.
Excellent. So what is an object in JavaScript? I'm just going to ask if someone to mute if they're not talking. I think it might be Tomoya or
I'll check it out.
Path.
Yeah, I'll just pick Tomoya.
Yeah. So what is an object in JavaScript? Anybody know? Well, the concept in programming, right? For those who are relatively new to programming, again,
there's a collection of variables and functions.
Yep. So collection of variables and functions, right? So we've got, say maybe a variable like might be something like foo, right? Bar is this variable, and then you might have a function, right? And that function might be like, say, hello, right? It might be like console.log, right? Say hello. Let me just set my syntax here to JavaScript. Is this zoomed in enough? You guys can see this, okay? Or do I need to zoom in a little bit more? I'll zoom in a bit more, just for the people who need glasses. Cool. So, actually, fix this. So, a collection of variables and functions is an interesting definition, right? What else, right? So, object one. Again, I'm just going to ask you guys to put yourself on mute. There's quite a bit of background noise. So that's one example. Collections of variables and functions sounds pretty accurate. Has anybody heard of a concept called an instance before, or in object-oriented programming? We talk about the instance of an object, right? What exactly does that mean?
So the object is just a blueprint of what you want to do, whereas the instance is an actual implementation of it.
So the object is a blueprint. So you're saying this is a blueprint?
That's a blueprint until it's instantiated.
Technically, this is actually an instance.
Okay.
Technically, because see how we've said equals here, and we've created a JSON. So JSON, for those who don't know, right? So JSON, I'm just going to put this in comments. So JSON, not M, N, stands for JavaScript, or rather Java script object notation. So you are very correct. I think that was Andrew. You are very correct in that an instance is kind of like the version or a manifestation, if you will, of a blueprint. But this isn't actually a blueprint. This is the instance itself. So that begs the question then, what is a blueprint? And how do we write one? Anybody know?
It's a class.
In latest versions of JavaScript, there is a class keyword, so you write it like you would on almost every other language.
Yeah, so a lot of languages have a concept of a keyword called class.
The name of the class.
Yeah. So we might have something like foo, right? Then we have these brackets, and then we have some stuff. So how does this differ to this? What are the distinctions here?
The values are set.
Yeah, the values here are actually set. So I can come and go log, right, object1 dot foo, right? I don't have to call new object1 dot foo, right? I just say object1 dot foo, like that, because this has already been instantiated. So I'm actually going to save this. I might just, where should I put this? Yeah. Do I have a webinars folder? Yeah. Call this J or OOP intro. Let's call this 1 because we might have multiple files. So I'm going to go ahead. You guys can load this into Chrome or your browser of choice if you would like. I'm just going to run this through Node.js. If you don't have Node.js, you don't need it. Don't worry. This stuff will work fine in the browser as well. So if you do have Node, I'm just going to go node 1 for that file that we just created. Actually, I'm going to open the folder as well. Yeah, there we go. So if we actually run this file, right, that should say bar as the output, because we're logging object1.foo. Oops. Node 1. Right. So we see that terminal output here. Now, if you're running this in Chrome or Firefox, it would log it in a console log. So how is this different to this class here? So can we do the same thing, right? Can we come in here and go foo equals bar? Right? Does this work? What if we go log console.log foo.bar? Does this work? What happens here? Okay.
It works.
No, we don't. So it gets undefined.
In the past.
Say again.
You can initialize variables up there. I think I've done it in the past.
Maybe we can.
Of course,
but in this case, right? Well, this is the blueprint as we talked about earlier.
It'll be clear if you do a different value, like bar 2.
Different.
Yeah, good point. Right. Let's say lorem ipsum. Right. Lorem ipsum. So we're getting bar undefined. I'm going to move this over to the right. Hopefully that might make it a little easier for you guys to follow. Is that better or worse?
Better.
Better? Excellent. So just clear the console and there we go. Great. Okay, so we run this node 1 and we get the first one works. Right, this console log works, but the second one doesn't. Sorry, we'll change that to lorem. The second one comes back with undefined. Right, what's going on here? Why is this happening?
you need to initialize the values in the constructor, so you have to make a constructor inside class if you want to initialize values.
Constructor.
You need to create an instance of the foo class.
An instance, constructor. These are a lot of terms we're introducing here. So let's break these two things down because they're very important, and you guys are both correct. So we have this here illustrates exactly the distinction between an instance, right, and a blueprint. So if you're an architect, right, you designed this incredible building, and it's got all these features to it. But as we say in some other areas of life, the map is not the territory. Right? The blueprint is not the building. I can't go and step into that blueprint. I can't work from there, can I? I can't take shelter from the rain inside this blueprint. Right? What has to happen first?
We have to build it.
Yeah, the engineer comes along and says, I'm going to follow the instructions that the architect has given me. I'm also going to add my own instructions because I'm an engineer. I need to make sure those things are stable, right? And I'm going to follow the instructions that the architect has given me, and I'm going to create it. The builder creates it, right? So that's what is referred to as the distinction between an instance, right? The building itself. Let's actually use the building example, right? Building. So maybe we have a name, and then we have Empire State. Actually, what's a famous Canadian building? The Toronto Tower. CN Tower.
Yeah,
CN Tower, right? So, or Seattle Tower for those who have joined from Seattle. So how do we go from this to this? Now somebody, I think it was Shane, said we have to use the new keyword, right? So what does this look like? So if we go const, we're creating a new variable, and we'll say CN Tower equals, right? Equals. So like this, right? New building, like this. Let's see if this works. So we'll change this around. So CN Tower, and we'll go name. And there you go. Now technically, you should put these parameters around it. You should call it like that. Right. So now we have an instance. So CN Tower is the instance, what we call the instance of the building class. So I'm going to pause here. I'm going to get to, I think it was Josh's comment about constructors in just a second. But I'm going to pause for a second. I want to make sure this all makes sense for you guys. Does anybody have any questions on the JavaScript object notation, commonly referred to as JSON?
So I just have one question.
Yep.
Yeah, because the JavaScript is dynamic language, so that is why when we set new building, we don't need the parentheses to call the CN Tower, right? Because
I believe so, right. But it's always good practice to do this.
Yeah. So the parentheses here just when you have argument. So when you have argument in the class, it is mandatory, right?
I can't quite hear you, mate. It's a bit muffled. There's a lot of background noise.
The argument for the class.
Ah, yes, the arguments, and then we're about to get into that. So that was Josh's comment about constructors, and we will get into that. So thanks for bringing that up. But before I move on to constructors, was there any questions around JSON structure? Around? Yep.
I have one question. So on line 18, you have name equal to CN. We have to do equal, or we do semicolons there? Or just go?
We have to do equals. So that's the distinction between JSON format and class format.
Okay.
This won't work.
Hey, Tristan, if you want to leave the name blank, like you don't want to give it a blueprint value, you just leave it like that. Just have test.
There you go.
Yeah, so just leave the name. Okay, cool.
Yep.
Yep. All right.
Let me just try something for a second. Let's go. Yeah, let's try this. Building.
Tristan?
Yeah, mate.
Yeah, so in classes, when we define variables like that, we don't use const, let, or those, right?
No, you don't. Not on this level. So this is probably a really good thing to bring up, right? Is what is the name of this? Because it's not technically a variable. It is a variable in practice, but the technical term is a little different. Does anybody know what the technical term for this
Property?
for this here? It's a property. That's correct. It is a property that belongs to this class. Now, this is a function, right? Does anybody know what we call functions that live inside a class?
Methods. Methods.
So, a method, that is correct. So we have properties and methods. So this is the name property, right? Now we can also have methods, right? So this might be maybe rename, right? Now in here, we can do something. So this is what we call a method. So this is the rename method, right? So we'll do this later. We'll get to this a little bit later. Is there any other questions on anything we've covered so far?
Yeah, I just saw a question, but I think you might be coming to later on. It's about the visibility of these properties.
Well, as we saw before,
That'll be public, right? It's visible. It's
so see down here.
All right.
We can access this. That's what we call a public property. Now in JavaScript, we've also got a private property, which we signify with the hashtag. So see how now, right, it's set to undefined.
And what about if you were to, like, does JavaScript have the concept of the package visibility? If you're using
package.
Packages. It's in Java.
Yeah, it's like a Java thing.
Yeah, if you're in a different file, but you're within the same folder, you can see it. But if you're in a different folder, you can't access it.
Not exactly. So JavaScript works with, in at least a Node language, right? JavaScript works through modules. So this might be, say, module JS. Now let's say this is const private variable equals 1, 2, 3. But what I can also do is module.exports equals, or module.exports dot something equals hello. Right? So I can actually between these two files, actually I'll create another file. So module 1 and module 2. So let's say module 2 wants to use the first module. Right? So in module 2, let me just try and bring that over. Come on. There we go. So in module 2, we want to import. So we'll say const module 1. And you have to explicitly import these things. Equals required. Some other languages like Python and Java and C and whatnot, they have a very different style of how these files relate to each other. In JavaScript, in Node, you have to require them manually. Right? So you actually pass the name. Now, if you pass in a path, a relative path, or an absolute path, the Node system is going to try and find that file on your computer. If you just pass in a name, Node is going to try and look that up in the Node modules folder, which is a very, very different thing. And we're not going to get into that today, but this is kind of a little bit about how these modules work. So in here, I can go log module 1 dot something because we explicitly exported it. So this will work. If I run node module 2, it'll say hello. However, right, if I try and say private var, right, that's not accessible. It'll give us an undefined. because we're not exporting that from this file. Does that answer your question? Is that around what you guys were asking?
Can we also export class as well?
Say again, sorry?
Can we also export as well? So you export just the string, hello, but I was just wondering if we can still export class.
Classes, yeah. So you can export lots of things, right? So you can go module.exports. Let's say building, right? Using the one we were having before. Equals class, right? So class building. Right. Bar. You can come in here and go const cn tower equals new module 1 dot building. I can go cn tower dot food. And there you go. So you can export whatever you want, any JavaScript primitives. So classes, functions, variables, they can all be exported through this syntax. Now this is what we call a named export. You can also do a generic export. So you can go module.exports equals, right? No name here, no dot something, just module.exports equals, and let's just return a function. All right, console.log hello world. So if we come down here and we just go module 1 and we just run it, we call it like this. Hello world. There you go. So you can actually export a default something, and you can also export multiple things, and you can actually do them in combination with each other, like we're doing here. So that's a little bit about how modules work. This is different to object orientated, but it is somewhat related, because you'll often write classes in their own respective files and then import them like this. So I suppose it is a pretty good thing to run through with you guys.
Yeah, this is good to see.
Yeah. So it's going to let me take that down the bottom.
I was looking up the documentation about classes in JavaScript, and I only can see for field declaration for the visibility. They only seem to have public and private. So
yes. Well, actually, no. There's also something called static.
Yeah, but in terms of just the visibility, like whether you can use them or not. There was some other thing I was thinking about from Java. There's a third one. There's private, public, and then there's package. But to be honest, I've never actually seen package used before. So
I've never heard of it. What's the concept? What's the idea?
So if you have, the way you have your files divided into folders, right? So say your JavaScript files are in folders. So in Java, all those folders would be a package.
Mm-hmm.
So each folder is a package.
Right.
Each directory is a package. So if you have package access, then let's say you import module 2, and then if you had instead of private var, you had package var, then module 2 would actually be able to access the package var because it's within the same folder. But if you were to import module 1 to a file in a different folder,
I see. So it says essentially it's just localized to that directory.
Yeah, exactly. Yeah, it's probably not that useful. So public and private anyway are the main ones I've seen. But
yeah.
I think the other one you were looking for is protected.
Yes, protected is another one. That I don't know if that exists in JavaScript. I know it exists in TypeScript for sure. I don't know if JavaScript has an implementation of that yet. I might be wrong. Let's actually Google that.
I don't see it on that.
Does JS have protected? I know TypeScript does, but I don't know. Yeah, they have to hack around it. They might eventually add that to the spec. So for those who are interested, like JavaScript is constantly being updated. There's always new versions of JavaScript coming out. So that might be in the works. We'll get into that in a second, because that's actually a really good point. There's something I've had pinned that I really want to address, which is a point that Josh brought up, which is the constructor. So was there any questions on modules before I move ahead? Nope. Great. I'm gonna rename that to class because it's a bit confusing. Okay, so yes. Okay, so so Josh brought up this concept called constructor. What is a constructor? Anybody know?
Yeah, basically,
A constructor is a function that gets called.
Sorry, Josh, go first.
An instance of a constructor is a function that gets called whenever you're
whenever we create it, right? So we learned what instantiating is with this new keyword. So a constructor is, I think you said, a function that gets called whenever you instantiate a class. So where does that function live? Is it outside? Is it building constructor? Is it out here?
Inside.
Right, it's inside the class. So in here, right, constructor. So you'll notice this follows the same syntax as a standard method. This is a special method, right? It gets called automatically. You don't have to call this, right? So this gets called automatically. Spelling is very terrible today. When you call new. That's a very important distinction between a constructor and a method. A method is something that we call manually, or that the object itself calls itself. So let's get into this. Right? Let's say this name here is the default CN tower. But let's say we want to give the opportunity to override this variable, but it's a private variable. So we can't change it outside. We can't come in here and go CN tower dot name equals Empire State. That's not possible. We can't do this in JavaScript. Private field. Right. So we can't access it. We can't even access it outside of it. Right, we're not even doing it. We're just trying to access it. This will throw an error. It's not possible. So let's say we do want to give the opportunity to update this. Now let's say name is say public, right? But let's say we have like the security code for the building, and we want that to be private. Right? Equals say 1, 2, 3 to begin with. 1, 2, 3, 4. Now let's say that when we create a building, we want to be able to tell the building what custom security code we want to use. And we don't want to expose this with a public method like change security code, right? Because that's a hole. That's a security flaw. Anyone can come along and call that. All we want to do is we want to have the security code access only for those who know it when they create the building itself. So this is a really good example of where we would use a parameter inside our constructor. So in here, we'll say security code. Now that's going to be a number, right? So let's just do a little bit of a type doc here. And the parameter here is going to be a number. And that's the security code. And create the new building. Right. So in here, we can say if security code, this dot security code equals security code. So now, because we're inside the class, because we're inside itself, we can access our own private variables. That's okay inside here, but outside we can't. Right? So let's create maybe a method. Let's call this authenticate. Right? So that we can get inside the building. Authenticate. Now let's say we pass in, right, to user key or user password or attempt. That's going to be, we're going to check this against our security code. So we'll say log or return, right, attempt equals, right, this dot security code. So this will return a Boolean. So let's say we pass in an attempt, which is a number. Right. This is user's security code. Right. Test or attempt to gain building access. Right. And then this returns a Boolean. Successful or not. Okay. So, is there any questions on anything we've just covered so far? So, just to recap, right? So, we're working with this constructor idea, right? Something that I think mentioned is a function that gets called on instantiation. Right? That's a very beautiful way of describing it, because that's exactly what happens. It gets called automatically whenever we create a new building. Now, you can have multiple buildings here. Right? We can have the CN Tower. We have is it Seattle Tower? Is that what it's called? Seattle Tower. We can have the Empire State. Right. All these different buildings. These are all different instantiations of the same class. Right. So we should probably also give an opportunity to change the name. So we're passing in the security code, but it would be nice if we can also pass in the name. Right. So we'll say if name this dot name equals name. So we'll update it. Right. So we should update a little doc here. String name of the building. Passcode.
You now have a 2-argument constructor, right? So if you did not, if you tried to make an instance of this object with no arguments, would you call that constructor? Because those aren't default values; those are just 2 values, right? So
that's a great point. So we actually do have default values already, as you see here.
So you say new building, you don't have any arguments. You call it 3 times. Would that call that constructor, or would it call a different constructor?
That's a great question. So JavaScript does not have a concept of overloading. Okay, other languages like Python, I think, has it. Java, I'm pretty sure, has it. So what is overloading? Overloading is actually writing the same function or same method in different ways, and it all depends on what you're putting into it, which I think is what you're asking. So, for example, you might have constructor with no arguments, right? That sets this dot name equals cn tower. This dot security code equals 1, 2, 3, 4. Now, depending on whether I call it with 2 arguments or no arguments, it will run a different function. Right? This is not possible in JavaScript. JavaScript does not work this way. Other languages do. You can also return different types of things here. So it gives you more flexibility. Does that make sense? Does that answer your question?
That answers the question, yeah.
Great. So yes, they typically you would the other thing as well is if this starts to get unwieldy, so if you start to have like foo bar, like multiple, like lots and lots and lots and lots of variables that are all parameters that are all optional or have defaults, typically what you would do is you would reduce this down into settings. Right, and you guys might have seen this. So now we'll pass in name, right, cn tower, right, security code, right, 1, 2, 3, 4, right, and then in here instead of saying name, it'd say right settings dot name. Security code would be settings, right, and that way instead of having, you know, in the example before, you have like Seattle Tower, and then you have security code 1, 2, 3, 4, right? And then you'd have something else, like maybe it's the address, like 1, 2, 3 Fake Street. And then you'd have how many people work there. So let's say it's 800 people. And then you have a list of companies that work there. All right, so you got Apple, Google, Microsoft. Right. So this becomes ugly and annoying, and you're not quite sure. Like maybe you go, all right, well, I want to break one to new lines. All right, to break it up. Right. This starts to become hard to read, and I also don't know what each of the. I have to keep referencing the docs, right, on what each of the parameters is, right. So that's why this method, right, where you're passing in just an object like this that has all of the names on them, right? This makes it a little easier for us. Now in other languages, for example in Python, right, I can go const me equals new person, and I can actually do named parameters. So I can go name equals, right, and I can put these in whatever order I want. Name equals Tristan, right? I can do age equals 26. So I can move these around, and it doesn't matter. So that's kind of this here is JavaScript's way of attempting to do that. So you have 2 options. Now, when would you use the settings option, option 1, and when would you use this method? What do you guys think?
When there's a lot of variables you're trying to pass, and you
Yeah.
you use the settings method. When you only have 1 or 2 variables, you don't need the setting.
Precisely, yeah. So I'd say like once we start getting to about the 3, maybe 4 mark, I'd start to look into converting it to a settings object like this. In this case, you know what? Let's actually stick with our settings object idea. Right. So we've got the name and security code. So is that okay with you guys, or would you guys prefer to use the individual parameters? Which one's more useful to you guys right now?
Let's go with settings.
Yep, settings. It's a bit clearer to read, isn't it? You know, you can see. You know what? Actually, let's attempt to do a smart version of the overloading in JavaScript. Right? Let's say we provide both options. So if we pass in the first one as a string, right, we're going to expect this syntax. So let me show you how we would do this inside JavaScript. So we want to provide this option, and we want to provide this option here. So how does this look inside the constructor? So this here is going to be either settings or name, and this here will be the passcode. Right, now this passcode potentially will be undefined if in the first example, right? Because we're not passing a second argument here. So settings or name. Let's do a little bit of a check here. So if settings or name type of equals a string. So if it's a string, then we're following this syntax here. So this dot name equals settings or name. This dot security code equals security code. Right? That's the first option. This is how you would manually do the overloading in JavaScript. Otherwise, right? Let's just say, just rename this const s equals settings or name. Right, just to alias it, it's a bit easier to read. So what have we done here? We've said if we pass in a string as the first parameter, then we want to say the string is the name. And then we also give the option of passing a second parameter, which is the security code. Now that only works in this format if the first parameter is a string. Now the second option is what we've got here, where we're passing in a settings object. And then we simply just extract out those settings, and we put them onto the object itself. Now, here's a fun fact. If you're not using private variables and you just want to do a one-to-one match, you can do this. Actually, someone tell me, does anybody know a one-line way to get all of the settings options applied onto the class? For those who are JavaScript wizards. Anybody have any idea?
Destructuring.
Subtract operators.
Say again?
Subtract operators. Subtract.
I don't understand.
Destructuring.
Sorry? Destructuring, we could. So we could come in here and go const equals settings, right? And then go const name, const security code. But we still have to manually go through each one, don't we? This dot name equals, right? So it doesn't really change it for us. Someone said it's something else, but I'm sorry, I couldn't hear you correctly.
I think he said spread operator.
Spread operator. So that's essentially destructuring. Almost. So who has heard of the method on the object or object class called object.assign? Has anybody heard of this before?
Yeah, heard of it.
Yeah. So in a simple example, right, we have const a equals foo bar. Right, we have const b, right, lorem ipsum. Now, if we go here, right, object.assign, right, a, b. So what that's going to do is it's going to take all of the properties, of object B, and it's going to apply them to object A. Pretty cool, right? So it manually does all that for us. So in the event, right, this is not private. If this was just a standard variable, that's what we could do. We could do object dot assign. Now, what would we put in here, team? This. But we've been using. I haven't actually broken down what this is, so I'll get into that in a second. This, and then the settings or name. We know the settings or name is an object. But this only works when the security code is not a private variable. But it is a private variable, so that's not going to work, unfortunately. I don't think it will. Someone should test that, but I don't think that will work. Does that make sense on how we can use this very quickly? Now, in theory, and for those who've been part of our Express tutorials and putting data from an API into a database, right? This will actually take anything that the user puts and will put it onto the object. So it's probably not the safest thing to do. Okay, a destructuring approach is safer because you're picking and choosing the valid options of the settings. So that is how we would. I'm going to comment this out as well.
Tristan, I just realized Marcy was telling us the name of the Seattle Tower.
Oh, what is it? What's it called?
Space Needle.
Space Needle. That's right. I love it.
Space Needle.
Thank you. Space Needle. There we go. Updated. All right. Okay, so let's log these out, and then we'll go for a short break. So let's make sure this is all working. Log. So space needle dot name. Now we would expect this to work. So this is method 1. Sorry, actually this is method 2. So overload method 2. And this is overload method 1. And this is use defaults. In fact, because we've already got the defaults on the CN tower, let's move this down to Empire State Building. So just move these around a bit. Okay, so this is going to do the defaults like we've defined here. Then we've got the overload method 1, which is allowing us to take in a settings object. And we're checking if the settings object is a string, right, like we've got in the second option, then set the string and the passcode. And if settings object is otherwise, right, if it's not, then attempt to assign the properties. Right, we should realistically be checking to see if it's an object here. But I'm lazy, and there's other things to cover on object-oriented programming. So, any questions on how the defaults work, how overloading works, on how we've done this, how object assign works? Any questions on anything we've covered so far?
So is the method similar to how you would create, excuse me, multiple objects at the same time or multiple instances at the same time? Let's say I need to create 100 objects. Mm-hmm. Is it the same way as you would perform that in Java or something like that?
So that would just be a loop or something. Like if you wanted to, you could have like the names. If you wanted to get really fancy, you could have the CN tower. All right. You could have the Space Needle. Oh, I'm going to change that to Empire State. All right, CN and then Empire State. All right, and then you do .map, right, and then you have the name, and you pass that name into new building, like this. Is this kind of what you mean? And then you have the const buildings, like this. And then in here you go buildings 0, right, dot name equals CN tower. Is that what you're referring to?
Yeah, I think so.
Yeah. So you can loop over things and create them dynamically. Right. So I'm just going to comment that out for now because that's just another way of doing it. That's very common. You'll very often loop over things and create objects.
Mm-hmm.
And so that will create as many instances as you want.
Mm-hmm.
All right. So let's check this. We haven't run this in a while. So let's actually see if this is working. Not read property name of undefined. Ah, yes. Okay. So in this case, right, we're not passing in anything. So type of string fails, else this will also fail. So we have to check if settings or name. We'll just check that it exists. In fact, let's do that at the start. I like to do my non-conditionals or my negations at the start. If no settings or name, return. And that should hopefully get around that problem. And there we go. CN Tower, Empire State, Space Needle. And let's give a little bit of context to these. All right. So overload. Slug that out again. There you go. So the defaults to CN Tower, the overload method 1 is what we're doing here with the settings object. And the overload method 2 is when we're passing in the string. So, any questions on anything we have covered so far? Would you guys like me to paste this code, or have you been following along? I'll paste it up.
I think we can use the JavaScript Advanced for this.
Yep, that's the one. Where are we? For those who are not in our Slack channel, I'm sure someone will provide a link. I highly, highly recommend joining our Slack channel, especially if you're learning JavaScript and all this stuff. It is a really good resource for asking questions, getting help on stuff, sharing things, finding buddies to do projects with, working on Project CM. Like, there's so many things. I really recommend joining it if you're starting out. You don't have to do this process alone. So let's take a short break. Let's come back at 20 past. Next up, we're going to cover. I think we're going to start to jump into some more object-oriented specific things around inheritance and extending and overloading and overriding. Sorry, static stuff, and yeah, there's a lot of really fun things we can run through today. Has it been useful so far, team? Has this been beneficial for everyone?
Yep.
I've enjoyed so far.
Yes.
Excellent.
Yeah, good.
Yep.
Marcy needs to leave. So thanks, Marcy. Thanks for coming. Cool. I'm gonna go grab some water, but let's come back at 20 past, team. I'll be back.
All right, cool.
All right. How we doing, team? What do I need to know? What do we need to know? What have we learned so far? What's standing out for you guys? For those who've been doing JavaScript for a while, is there who's been doing JavaScript for a while? Is like, oh, I didn't actually know some of this stuff. I'm curious.
Yeah, like when using frameworks like React, right, for a while, it becomes like you stop using those concepts.
I know.
So it's good refresher.
I know, and once you do React for a while, everything starts to look Reacty, and it's not even really JavaScript. Eventually, it's kind of just React. So that's why I keep saying to everyone, be very careful when you do that, because what happens when React goes away and you're left with nothing? So Sandy says settings or name is not officially declared. What do you mean by that, Sandy, if you're still with us? If you're not with us, I'll ask that again later. Oop. Did you turn your microphone? I'm interested to know what you mean by that, because
yeah, just what type of variable it is.
It's a parameter.
So
are you familiar with the concept of a parameter?
Yeah, but you still have to know what type it is that you're passing in.
Well, that's the problem with JavaScript, is it's not typed. And that is precisely the reason why we use TypeScript, because you don't know. In JavaScript, you don't know. Unless you've documented your functions very well, and your classes and methods and everything. JavaScript can be very challenging to use sometimes, because and that's the reason why it has gotten so much criticism over the years, is because it's what we call weakly typed, right? Python is the same. You don't know what you're gonna get. Python has some other stuff that makes it a little bit safer, but JavaScript, you can do whatever you want. Yes, Frank will definitely go through this. I was going to bring that up, and that will make sense in context of inheritance, and we'll get to that later. Marcus says, sometimes I feel like the concept of classes is to try to force JavaScript to do something it wasn't made for. Marcus, you might be right, mate. We haven't discussed the prototype before. So this is all under the hood. It's using a prototype. I learned JavaScript using prototype syntax, which is all function. It's very functional based. Kind of it's a pseudo object orientated. It's not really object orientated. And you might be right, but the nature of our reality is that JavaScript is wildly popular, and one of the most it's on one of the most popular environments, which is the web. We don't have, well, that's changing now with, I was going to say we don't have any other options, but that's actually changing now. So who's heard of a thing called Wasum? WASM. Has anybody heard of this before?
As in like a alternative platform for applications.
Alternative to JavaScript on the web.
Oh, I see. Oh, I get where you're going.
So Wasum, what is this? It sounds like a noise that a wasp would make as it goes past your ear. It's what we call web assembly. This is way out of scope for today's. I don't know enough about Wasm to really talk about it in great depth. But just to address some stuff that Marcus was saying, I feel like this is not necessarily the great, like JavaScript is not meant to do this stuff. maybe you're right. So Wasum allows you to, depending on the language and the transpile and everything, it allows you to compile other code. Java, C, very commonly and very popular right now is a language called Rust. So Rust is having a huge surge right now because of its aptitude for Wasum. Now these languages, they're much more efficient. They're much more lower level. They're much faster, much more memory efficient than JavaScript is, and the support for these now is growing. So this is a very interesting time for the web, because it means prior to this, right, we had a couple of different attempts at this before. We had Flash, we had Java servlets, and a few of these things. They've all been scrapped. The web community scrapped them because they were unsafe, they were, you know, they were slow, they were ugly, they were resource intensive, mostly to do with security holes, right? And so as a result, the web community has really cut itself off from a lot of the other developers and the other programming communities, because it's kind of said, well, JavaScript is king, and if you don't like that, well, really, that's kind of what it's said to everyone. And it's interesting because the web, from a consumer perspective, has become really, really powerful, and more developers are going, hey, I really want to build stuff on the web, but I don't want to use this crappy language called JavaScript. I want to use my languages, these real, powerful, heavy lifting languages like Java, like C, like C++, like Rust, like even Python. So there's this resurgence, I think, about this concept of WebAssembly, and it's not specific to one language now. It's not like the Java servlet page where it was just Java, or it's not like Flash, or I think it was ActionScript. I think it was called. I forget exactly what that was. It's a assembly language for the web, which allows any language to interface to that. Very interestingly, brings a lot more developers onto the web. So, you know, I actually kind of have this feeling, this inkling, that knowing JavaScript is not going to be enough anymore. You know, you used to be able to say, as a web developer, all you need to know is JavaScript and you'll be fine. But now, I don't know. I mean, if you look at something like Figma, I know we're a little bit over time. Is this still useful? If this is not useful, I'll shut up. But
continue.
Yeah. So who's heard of Figma? Right, Figma is this new design platform like Illustrator or like Sketch or Photoshop, but it's all based on the web. And that's all the engineers there are using a combination of JavaScript, but there's a huge WebAssembly component to it as well. So, you know, there's so many opportunities in this, and it's not really talked about, right? The boot camps don't talk about it. I haven't heard about any university courses that talk about it, but I feel a responsibility to tell you guys. I think you might want to look into it, because I don't think that being just a JavaScript framework developer like React, unfortunately, I don't think it's going to be safe anymore.
What is this, WebAssembly?
Yeah. Now here's the other thing about WebAssembly, right? Who knows one of the biggest technologies right now that is going to change the world forever? Right, we should know this as developers. What's it called?
WordPress.
Oh my God. Kick him off. Kick him off.
Cryptocurrency.
And you too, Andrew. Neither of you are allowed on this call anymore.
Wi-Fi.
Wi-Fi. Pigeons. No, it's machine learning. Now, machine learning, has its origins in things like Python and some of these other languages. And guess what's going to happen with WebAssembly? We're going to, and we've already started to see this, we're going to start seeing machine learning models run on the client.
Oh, wow. In the browser.
In the browser.
Impressive.
It's incredibly impressive. So the landscape of the web in the next 5 years, I would say, is going to shift dramatically. And there's going to be a lot more. I don't mean to shit on web developers, but there's going to be a lot more like real developers, like heavy developers that come in with years and years of experience working in very complex, deep environments around optimization and memory allocation and all these like hardcore engineering principles that most web developers go, I don't need to deal with that stuff because JavaScript doesn't really have the ability to deal with it properly. So don't need to learn it. I'll be fine. We're not safe anymore. Right? This hasn't quite hit mainstream, but I've been following it pretty closely for the past couple of years, and it hasn't died yet. So I really believe that there's going to be a big push for this eventually. We're already starting to see large companies pick it up, and with this fuel of machine learning and deep learning, that is really going to, I think, create a lot of opportunities for WebAssembly. So if you are interested in really looking at some interesting stuff, I would definitely, and you don't like JavaScript and you don't want to work with it, a couple of years ago I'd say, well, tough luck. Now I'm saying, okay, there are some options here. Now I don't know who's employing to this stuff quite yet outside of Figma and a few other places. So I don't know the practical application of bringing this into your standard startup that just wants to build a dashboard. That's not really useful. If you just want to be that kind of developer, fine. But if you want to work on really cool problems.
Hey, Tristan, just before you get started, I want to just mention as well, like it's very easy to fall into the mindset of, like it's almost like a rat race of chasing the latest language, and you're kind of just getting overwhelmed. You kind of feel like you're just, I gotta learn this, I gotta learn this, I gotta learn. That's not the mindset. The mindset is you're a developer and you're a learner, and you're gonna just learn whatever you need to learn to use, to do your job. And if you learn JavaScript, great. You can then learn whatever the next thing is. And it's not, if you're coming into a career as a web developer to say, okay, I'm going to learn JavaScript and then that's it. That's the wrong mindset. The mindset is, I'm going to learn whatever it is that is needed now. And over time, in 5 years, what I'm working with and what my daily, whatever I'm learning in 5 years is going to be different to what I'm learning now. You're just a learner, and it's actually very exciting to get involved with that. It's not something to be overwhelmed with or afraid of. It's actually something to be drawn into and embrace, and just to think, this is incredible. I'm going to get to learn these cool technologies, and this fun I'm having learning JavaScript. Once I learn JavaScript, there's going to be something else I can learn, and for my whole career, I'm just going to be in this exciting phase of learning and applying my experience from whatever I've learned before, applying that to the next thing. It's cool. It's really cool.
Yeah, I think the name of the game is flexibility. Right? Don't pigeonhole yourself and think, oh, I can only do this. No, we're human beings are one of the most incredible organisms, and our brains are so capable of just picking up all this new stuff, ideas, technology, concepts, and very few of us are really truly operating at full capacity of the human potential. And I think as developers, it gives us a very exciting opportunity to really test that, as Shane is saying, and just constantly be picking up new things and learning and really trying to do whatever's necessary to solve the current problem at hand. We've got a couple of questions. So Sandy says, not sure what you mean by machine learning. Do you mean like assembly language attaching your hardware? Not yet. I don't. There is a hardware component to the web, but that hasn't really seen too much. Like there's Bluetooth and a few things like that. What I'm referring to, Sandy, is AI. It's essentially the precursor to artificial intelligence. And Marcus says, don't worry, no machine is capable to keep up with the amount of new JavaScript frameworks that keeps coming up. That's hilarious. Yes. So, and I honestly, I think that's something that a lot of real developers, I don't want to say real developers because it makes it feel like we're not really developers, but let's say like non-web developers, they kind of laugh at us for this because every new day there's something else. And these other developers are going, what are you guys doing? Like you're going around in circles. So we have kind of attracted some very interesting criticism from the other development communities. So you're very correct on that, Marcus. Okay, so let's jump back in. Over the break, did anybody have any thoughts or queries or things they wanted to share or ask before we jump into object inheritance and this keyword? Or anything? Any questions on anything I just spoke about?
Can you talk about the scope in the JavaScript class?
Scope?
Yep.
So yeah, how long have you got? Scope. Yeah, scope is a very tricky beast in JavaScript. We can talk a little bit.
Confused about that.
Yep, we can talk a little bit about that. In fact, that plays into Frank's question about this keyword. So that's what I'm going to start with now, actually. Okay, cool. So I'm gonna. Should I continue with this? Yes, we'll continue with this file. So I've been using.
Sorry, Christian, I have one question.
Yep.
So like we have here overload method 1, overload method 2. So overload just basically means when we pass parameters or arguments?
Yep.
Okay.
Yep, so overload is passing in, it's a technical term in multiple languages, and overloading means you can pass in different things I think it actually technically means to get different results. But in this case, it's just multiple ways to pass in different data. Yeah. So good question. And any other questions before we move ahead? Cool. Okay, so we referred to this. What is this? All right. So we learned about the distinction between a blueprint, right? This whole thing is a blueprint, right? A very big blueprint, right? So all of that's the blueprint. I'm going to collapse that for now. So we've got our blueprint here, and then we've got our instance here. So what is this then? What is this? Well, this keyword refers to the instance. So whenever we create an instance, whenever we instantiate a building, right, it essentially creates a carbon copy of this blueprint. And this keyword refers to that copy, refers to the instance itself. Does that answer your question, Frank? I can't tell if someone wants to read out if he's typing. I don't think he has a microphone. Oh, he's got a special guest, that's right.
Can you says yes.
Cool. So, and we can use this in multiple places, right? So it's not just a constructor. Any method inside the class can. So like we're doing it here, right? So we haven't actually tried to authenticate yet. So let's break this down, right? So we're passing in the attempt, and we're comparing it to this .security code, right? Now the security code is going to be different for each building. So in the CN tower, it should be 1, 2, 3, 4. Let's say on the Empire State, we'll say 5, 6, 7, 8, and then on the Space Needle, we'll say 9,000. Right? So this is different for each one. This security code for the CN tower, when we call it, right, is referring to the copy of the CN tower. On the Empire State, this refers to the copy of the Empire State, this instantiated instance, this one here. And same for the Space Needle. So let's try it. Let's try and authenticate. We'll say log, right, CN tower dot authenticate. And we'll pass in 1, 2, 3, 4. Excellent. So that's true. So it returns true. What if we pass something else? 1, 2, 3, 6. Okay, so that doesn't work, right? So authentication is working. Now let's try it with another building. Let's try and authenticate with the same credentials, but for the Empire State Building. So trying to authenticate with 1, 2, 3, 4. This should hopefully return true for this one, and then false for this one. And there we go, true and false. So what that tells us is this instantiation is correct. All right, so we pass in 5, 6, 7, 8. True, true. So if you're writing tests for your code, this is what you would test. This is actually a pretty good example of a test case. There's a couple of them here, right? We should probably do a tutorial on testing one day. Maybe we'll do that next Saturday. How to test code, right? So that kind of refers to this. Now, I think it was Kang, you asked about scope, right? Did you have any particular questions around scope and what you meant by that?
Yeah, because I saw some guys ask about the var, let, and constant. And yeah, and I think it's like with different kinds like var, it can be global scope, but let is just like local scope style class.
Yep, exactly. So I would not use var anymore. To be honest, I don't use it in any of my code anymore, ever. To me, it's only ever let or const. That's really the only two that I would use. The reason why is let and const are two relatively new concepts. I think it's around 2016. Whereas the var has been around for, I think, since JavaScript was first created. So what is the distinction between them? I'm going to create a new file called scope.js. This is not object orientated, but is it still useful for everyone? Looking into this scope. If you guys don't respond, I can't tell if that's. Are people finding this useful? Like yes or no? Write it in the chat.
Yep.
Cool. Okay. So let's say we'll use a var. Right, let's say we have var, right, test equals 1. And then if we go function log test, right? And then we have log test. Right, what do we expect to happen here? Pretty simple. This is a pretty simple use case, right? So what do we expect here? Node scope. What are you guys expecting to see?
1.
Correct. All right. Well, once we actually run the function, we'll see 1. All right, now what happens if we do this, right? Let. What about here?
Undefined.
Undefined?
Or error?
No. We also see 1.
Oh, yeah.
Why is that?
Because it's globally defined outside.
Well, I wouldn't say that it's globally defined. I'd say this function here lives inside the scope where test is defined. Let's use a little bit more of a complex example. Right, function define test, and we'll say var test equals 1. And we'll get rid of this here. So we'll define it. So we'll say define test. Let's call it foo because I don't like foo. Right. So define foo and then log foo. What do we expect to see here? Now we're starting to get tricky. This is why people hate JavaScript, because it behaves like this. Any guesses on what we'll see here? Do we think this will be undefined or 1? What do we think?
Undefined.
Undefined? All right. Anybody think? Yeah, I think it's 1. Let's have a look. Oh. Oh, they've changed. Ah, Node has changed it. Let me put this in the browser. I think Node has done some things around that. Oh no, they must have changed that in the recent JavaScript version. That used to work. So I'm not sure why that's that used to work. All right, well I guess they've tightened up JavaScript, or maybe I'm doing something wrong, but I'm pretty sure that used to work. What if we do something a little bit more complex, right? So what if we move this function inside here, like this, right? So try this. Still saying foo is not defined, right? So let's say var foo. We'll move it outside, right? Now we should see 1. So this is kind of how scopes work. Is again, there's quite a bit of background noise. So if someone could please mute yourself. I think it's Balu. Just going to mute you. So this is kind of how scopes work. Is that depending on where you define them, right? They have access to different things. Now the difference between a const and a let, right? Const is not something you can change. So if you go const hello equals hello, all right, now if I try to go hello equals 1, 2, 3, that's not going to work. You can't do that. Whereas a let is just a. It seems they've locked down the var, so that's interesting. But let was getting around some of the issues that we have with var. So I would actually recommend looking up some of the there's some very weird quirks around JavaScript scopes that I would recommend going and looking them up. But for now, I'm actually going to delete this file because I want to get back to the object-oriented stuff. So any questions on anything we've just covered around scope or classes or anything? Cool. I'm actually going to create a new file for this one and call this inheritance. Inheritance. Okay. So what is inheritance? And I'm not talking about the money that you get from your grandma when she dies. Or I kind of am, actually.
So a class can inherit certain properties of another class.
What does that mean?
So say you have a class called animal, and then you have a class called dog. So animal can have something like species type or something. And then dog can use that variable basically, or method, you know, or either change it or override it.
Let's say walk. So how do I do this? Down here, and if I go const rex equals new dog, how do I do rex.walk? How do I do this? Because currently it doesn't have that.
Yeah, so you'll have to extend the dog
extend
to use animal.
So extends animal. So this is a very special word, right? This is a keyword in JavaScript. It says grab this blueprint and merge it with this blueprint. So use this as the base. Right?
Christian?
Yeah, mate.
So we can extend instances as well, or we just can extend blueprints?
Just blueprints.
Just
blueprints. You can't, yeah. You can't extend instances because they've already, once you've instantiated it, everything's been created. Okay. So you can't really tack things on. Now you can, like, technically, if we haven't got into this yet, but the old way you used to do things is this, right? Animal. All right, this would actually be your constructor. And I'm pretty sure this is how classes work under the hood. And then you go animal dot prototype dot walk, right? And you'd say equals function. Same thing here. This is how JavaScript used to look when you do object oriented. And then what you're saying is, you know, if you have the dog as well, so and there was all sorts of complicated stuff. This here, right, is quite nice. Trying to do that this way, it's kind of ugly. So you can do things. I forget exactly how to do it. Say function dog, and then you say like dog dot prototype dot walk equals animal dot prototype dot walk. I'm pretty sure there's a way to override this. You might even just be able to do this, right? To override it, and then if you say, let's say you create a dog, so const rex2 equals new dog. I should probably specify that these are different. So dog is dog2, animals animal2. Right, and then you can go rex2.prototype. I think works. Dot walk, and then here you can override it if you wanted to. But that's a much uglier syntax. I think you'd agree. So yes, technically you can, and you can still do that. I'm pretty sure I'm going to leave this here for you guys as reference. This is like, I have to check this exact syntax. I forget. It's been a while since I've done it. So forgive me if that's wrong. For the JavaScript purists, this is the old way, right? The old way. The new way is much, much nicer. Okay, so let's see if this works. Node inheritance. The animal walked. Excellent. So I'm sure there's more that we can do with this. What else can we do with inheritance?
You can override methods, so you can give your own implementation.
You can override methods. Yeah. Okay. So let's say we have walking and breathing. Okay. Breathe. Okay. So let's say instead of the animal walked, maybe we say the dog walked. Right. So let's have two animals now. This is just going to be a generic animal. Sorry, I'm just going to close my door for a second. So let's say we have the animal like this, and then we do the Annie.walk, and then we have the Rex.walk. So in this example here, right, the Annie.walk will call this method, and the the Rex.walk will also call the same method, but we've overridden it, as you see here. So this will actually, it redefines the blueprint. Remember how before how we used the analogy of the engineer coming through and taking the architect's designs and applying his own engineering principles to it? That's kind of analogous, to what we're doing here. It's like the architect defines something, but maybe it's not perfect. Maybe it's too broad, or maybe it's not specific enough to the current issue at hand. So the engineer comes on and says, actually, I'm going to use what you did, but I'm going to extend it, or I'm going to override it, right? To use my knowledge as an engineer, which is different to you as an architect, or to use my knowledge as an engineer to come up with something that's a little bit more stable, right? That's kind of the analogy behind how these two work. So let's have a look. So we see here, right? So the animal walks, right? Annie.walk. So we're not overriding it, and then we've got the dog walked. So the dog has now overridden what the animal does by default. So that's an example of overriding. I'll put that here. Overriding. This here is inheritance. Just to label these things for you. What else have we got?
Super keyword.
Super. Other than sounding like Captain America, what does super do?
It calls the methods in the base class.
Right.
Or if there's a parent constructor, it invokes that.
Right. So let's say, what's a good example? Let's say maybe it's asleep, right? So log animal. Let's say is sleeping, right? Is sleeping. Say is false. to begin with, right? And then here we'll say sleep is true, right? So what we can do in the sleep is let's say we want to do something extra. So this is different. This is different to overriding. Overriding says replace, right? What we're doing here is overriding with super. Now this is different because, like Rajat said, it allows you to execute something on the base of what's going on. So in this case, we want to call this super dot. Now, super is a special word like extends in class. Super refers to the class that we're extending from. So that's what super means. Almost imagine it like you're going up a level, right? So in this case, we can call super dot. Now this will be the instance. So super dot, and then we can go sleep, right? And then excuse me, let's say we want to add something else, saying log the dog snores. Right? So now the animal walks and then Rex walks. The animal sleeps. All right, let's add a little bit of a console log in here as well. Log. The animal sleeps. All right. The animal sleeps, and then the dog sleeps. Okay, so let's see what this does. Okay, so let's add a little separator here. Log. Okay. So the animal walked, the dog walked. So we've overridden it. Okay. The animal sleeps. The animal sleeps. So it's actually been done twice. And the reason why is we're calling this super.sleep. Now, if we log at the both, right, both of these, if we go log Annie dot is sleeping and dog dot is sleeping, right, they should both be true. Oh, they're not. Why is that? Oh, sorry, is sleeping. Apologies, team. There you go. So we could actually have some, in here, we could have some very complex logic that's going on in the base class. And the dog class doesn't necessarily need to know what's going on there. All it needs to know is how to call it, and then it can do whatever else it wants to do. So that's another example of overriding with the super. So we've got these two examples. What else have we got, team? What are some other things you guys are interested to learn about or know about object-oriented programming?
In relation to inheritance, I just confused that JavaScript is single or multiple inheritance.
That's a great question. Unfortunately, so what you're asking is, like, can we also have, say, class canine, or class maybe it belongs to a show dog class, right? So it's a performer, right? And it has a little thing called dance, right? It does some stuff in here, right? Can we extend both? Can we extend an animal that's also a performing animal? Does this work? performer. What happens here? Unfortunately, we can't. And there are tools and libraries out there to do a merge of these together, right? To merge that into a single class in which the dog can then extend. It's often called a mix-in. Right? If you Google mix-in JS mix-in class, you'll see there's some patterns and some examples and libraries here, right? This is probably a pretty decent article for understanding some of how the prototype works and whatnot. They're using the object.assign here that you see. We learned that earlier today. So I'll send this resource in the Slack if you guys are interested in learning that. It is technically possible, but not from an easy syntax perspective. I noticed that Frank says getter and setter. That's a pretty good idea. So what is actually, before we jump into that, was there any other questions on how inheritance works?
All right, so Christian, what you're saying is you can only have like one base class?
Yes, well, you can actually have multiple. So multiple, like that chain together. So for example, the dog could extend from the performer, and the performer could extend from the animal. So that will look like this, right? Animal, right? This performer extends from this, and the dog extends from the performer, and then which you instantiate into the new dog. Make sense? So you can actually chain this as long as you want. What I think it was Kang was asking is, can you somehow do this, where you've got the dog, right, actually comes from both the animal. I don't know what I'm doing exactly here, but trying to come together. Right, is this possible? Is this syntax possible? Where it's taking this one and this one, and the dog is coming from both of them. Is this possible? Technically, yes. From this syntax, unfortunately not. Other languages do provide that. Right. So, does that answer your question?
Yes, thanks.
Awesome.
Just on that point, Tristan, does JavaScript have like an interface concept where you can add multiple interfaces? Like a dog could have an interface animal and an interface performer.
TypeScript does.
TypeScript.
Yeah. So TypeScript is a bit of a game changer in that it does allow you to do a lot more extra things. A lot more extra. It's not very good English, is it? A lot of extra things. And it does some things under the hood where it doesn't allow for multiple inheritance, but you can implement interfaces to create a blueprint of a blueprint, if you will.
Right. Yeah, that's like that. I think that's basically how Java gets around it. So Java has one because if you think about it, like a dog is only going to be inheriting from, say, animal. So you're just making it more specific. So it's an animal, and then you're making it specifically it's a dog animal, right? But if you want to be able to give dog all of this other behaviors, like say performer, make it a performer dog, that's where you would use an interface. Yeah, exactly. So the dog extends animal. That's the type of object, but then the interface gives you a bit more of a, just kind of decorates the dog a little bit, makes that dog a performer.
right? So in this case, we've got duplicate identifier. What's this first one? I'm confused. I'm not sure why that's saying that. But what you can do is you can go extend implements. Exactly what you're saying, Shane. Implements performer. Now that will throw an error because this will now say dog is missing the following properties from performer, right? Dance, stage name, salary, and favorite food. So it's saying that we need to declare all of these things. This needs to be declared here. Make sense? So yeah, so TypeScript, and I'm pretty sure you can do multiple things. So if you do interface, let's say interface, let's also say it's a combat dog, combat animal, right? It can go and bark, and it can jump, right? And it can attack dog or attack animal, right? Not that I'm promoting violence. I don't know why this is. Sorry. The syntax is incorrect for TypeScript. This is not a class. This is meant to be a blueprint or interface. Now, if this doesn't make sense, if you're looking at this going, "What the hell is this?" Don't worry. You don't need to know this. So if this implements this, I'm pretty sure you can do combat animal. Yeah. So now it will say dog is missing the following properties from combat animal. So you can actually have as many together as you'd like. And then for the real advanced, you can actually have a type performing or combat performer. Right. So type combat performer equals performer and combat animal. So you've actually merged these two blueprints together, and then you can just use that quite simply by saying combat performer. Like that. So that's a little bit of TypeScript for you.
Yeah, it's cool.
Cool.
Yeah, it's cool to see these concepts just translating over to a different language.
I know, right?
Same fundamental concepts.
Yep. All the same fundamentals. Yep.
So TypeScript, they can like compile two interface into one, just one line of syntax like that.
Just like that.
Wow, that's so cool.
Actually, if you want to see some really cool stuff, right? You can do. Let's get funny. Let's get funny with this. Poor. Let's say poor combat performer. Right? We're going to take away the combat. Right? So we can say exclude. Right? Combat performer. Right? And then you can take away certain things. So salary. Take away salary. Right? Now, in here, right? If we add all the functions, so this should hopefully, I don't know why it's salary is missing from performer. I thought, sorry. So currently, right, this is saying, hey, we need to pay the dog because we're saying he's a performer, right? The performer expects a salary. Right, but we're going to, instead of saying combat performer, which is he's expecting money, we're going to call him a poor combat performer. In which case, that error should go away, I thought. Maybe not. Maybe it's the other way around. Maybe it's, let's forget, without. Exclude. There is a way to do this so that it's, I always forget the exact syntax. But essentially you're removing the, maybe it's the other way around. Let's try this. No. Is that not working? combat performer equals exclude. Yeah, I forget exactly the syntax, but there is a way to remove. You can actually pick and choose, so you can actually take out certain things from this. Again, if you're in JavaScript land and you don't know TypeScript and you're like, what is this? What is this madness? This black magic? Don't worry, you don't have to. I would recommend learning it at some point, but if you're just starting out in JavaScript, you don't need to know this right now. Cool. So before we get into getters and setters, was there any other questions on how inheritance works? Was there any? I'm just trying to think for myself. Is there any extra things that I should teach you guys around this? Whatever. Yeah.
Frank, I think somebody had mentioned, right, getters and setters as well.
Yeah. So I just mentioned before we get into that. Just trying to think if there's anything extra, because getters and setters are not specific to inheritance or object orientated. They're actually more of a generic thing. I want to think about like inheritance specifically. Is there anything in particular that we need to be aware of? Okay, yes, there is. Constructors. So we need to actually. So in this case, right, we'll have species. So we'll say constructor, and we'll say this dot species equals, and then a name of species. Right, and that is going to be species. So when we create a new dog, we don't want to have to tell it this is a dog species. But that would be very annoying because there's obviously a dog. So what if there was a way for the dog to pass that down the line and say, and pass that onto this? So we've already learned about supers, right? Super.sleep. So I wonder if the same thing can work for constructors. So let's say we have the constructor of the dog. We don't want to pass anything. So no argument. And let's say we have the constructor. Sorry, the super, so super, and we call it, and look, species. So in here, we can say canine. And that will be available. So if we do log rex.species, it says canine for us, even though we're not passing it in the constructor here. So we're actually overriding. We're doing an override on the or overload on the constructor itself. So that's a very important inheritance thing to be aware of. And also, a tip is you can't use this before you call the super. It's not good practice. Always call the super first before you reference this. So any questions on how I extended the constructor here? If I take this out, right? Neither the performer or the dog has a constructor. So when I construct it here, it's going to call this directly. So now if I try it, canine is not going to show up. It's going to be undefined because we're not passing it in. So that's an example of extending the constructor. And this is a good example because in here, right, we might have a really complicated constructor that has lots and lots and lots of different settings. And what you might do is you might create a class that just aliases all of that. It says, I'm going to pre-configure all of the settings to construct this complex animal, and I'm just going to alias it as a dog. For example, right, let's try this, right? It's the animal. Let's go back to our objects thing, right, settings. We'll say this dot legs legs number equals settings dot legs num, and we'll use the object assign. Right. So object dot assign. So like we learned last time, this settings, no private variables. Right. So, and we'll change these now, right, to this dot species. We'll declare them. We'll declare what we're expecting. So species will have legs num. I don't know if no, it's not going to work. I'll do it this way. All right. Is sleeping is false. We might have wings is a Boolean. False, so it's false. All right. Now, what we can do in the constructor is we can pass these things in. We can say species is a canine. Right? We'll have the legs number as 4. Right? We'll give it a tail, right? Tail true. I think a lot of animals have tails, so it's probably a good default. Right? So we don't have to pass in tail, but we're gonna, and wings is false. Right? The dog doesn't have wings. Right? That might be all we need to construct a dog. So now when we call it, we don't have to pass all that stuff in. But for this one, this is a generic animal. And let's say we do. Let's say we want to make a bird, the species bird. Right? Tail, say false. So it's a birdless, a tailless bird. Let's say wings, true. We want to override that. We actually do want to set it to this. Now let's say you don't want to do, if you want to create multiple birds, right, you don't want to do this each time. So what you can do is you can alias it. That's what we're doing here, is we're overriding the constructor for a complex base class. Does that make sense on what I just did there? And how super, it's the same thing, right? Like we called the super function before with the sleep, where the base class is going to do a whole bunch of complex stuff, and then we want to do something extra. It's the same thing here, right? Same thing here. In fact, this works at multiple layers. So in this case, we'll have constructor. Because remember, the dog has two classes that it's extending: the performer, and then performer extends the animal. So maybe for the constructor of a performer, we should have the show name, and then the base settings, right? So animal settings. So in this case, we'll say show name as a variable, and we'll say this dot show name equals show name. And then we'll also call super with the animal settings, like this. We're doing two things at once now. So now, in this constructor here for the dog, this super, right, is not going to call the animal super now. It's going to call this one here, because it's getting in the way. Right? Remember the chain that we had before? So the animal. And then we had the performer, and then we had the dog. Right, before, when we called the constructor, this didn't have a constructor, so it just went straight to the animal. But now we're adding it in, and we're also adding an extra variable, extra property. So this is when things start to get complicated with object orientating, because we've got multiple inheritance, multiple different types of constructors, multiple methods, multiple properties. Some properties are on the base class, some properties are on the middle class. Right? The dog doesn't define any specific properties. Right? So you're starting to see how it gets pretty complicated. So any questions? I'm going to pause for a second to let you guys let it sink in.
So I have questions. So actually, when everything goes more complex, do we use the UML to like style the classes and the properties?
UML. What's UML?
I mean, class diagram.
What, sorry?
Class diagram. It means, yeah, it
Class
just
diagrams.
Yeah. The
Oh, is it like it's like a database schema? Kind of. I've never even heard of this before. Yeah, I've never.
It's basically like it's like a documentation representation, essentially.
Okay, cool. I mean, yeah, you can. The thing is, right? This is where I'd use TypeScript, because with all these things that are happening, right, in TypeScript, you can actually document all of them, and then through documenting all of them, you have really good IntelliSense, where you, like, if for example in the dog, if I tried to pass in something stupid like false, right, in JavaScript there's no problem. In TypeScript, it's going to say you cannot do that. Right. So I really want to fix this error. I don't know why it's show name salary. Show name equals Rex. Salary equals. I'm not sure why that duplicate identifier. It's very strange. Not sure why, but essentially in here, right? If you try to pass false, right, that will give you an error saying expected 0 arguments. So let's create a constructor, and we expect the constructor to take a type. Let's say it's the name, and we type it. Excuse me. So in this case, right? Oh, and it also tells us that we need to call super, because it's extending from something. So it says, hey, you need to call super. So we call super, right? Now look, it's saying expected 0 arguments. Hang on, no, where is it getting this dog from? I don't understand. There seems to be another dog. It's just called dog 2. Where is that coming from? Oh, it's pulled it in from another file. That's strange. Must be the VS Code's IntelliSense. So I'm gonna rename these to other things. So sorry about that, team. And then hopefully, yeah, okay, that's still not working. So in this case, right, it's gonna say, hey, argument false is not assignable to type string. So we've explicitly defined it. So to answer your question, I think it was Kang, would you use UML? No, I wouldn't. I would use TypeScript, because TypeScript says, hey, you can't go ahead and do this stuff because that will break.
Partially because I just mean like we draw a hierarchy before we start do something like the class and method inside.
Yeah, I've never had a need to do that personally. If I'm working with a database, yes. So it's a very analogous to database.
So Tristan.
Yeah, mate.
Yeah, actually, what he means is that those UML, these are the things they teach you in universities. You know, like.
Oh, really?
Yeah, there are tons of types like class-based and.
I've never used.
So they like suggest that when you build a object-oriented system, you build these diagrams, and then it gives you a clear picture how the hierarchy of a software looks like. In theory, it sounds good, but actually, when you're implementing it, things change, right?
Yeah, it's like who's been on a software project where the plan is exactly perfect and the project has come out that way?
Not me.
Not a single bloody person. Right? Not even banks, who spend quite literally millions and millions of dollars on planning before they even touch a line of code. Not even banks get it right.
Yeah, I work with insurance projects.
Yeah, insurance is the same kind of thing, right?
Yeah,
so
it's
this
a
is
mess.
this is a development process called waterfall versus agile. I'm gonna try and find a picture for you to illustrate what I mean. So, there's no good ones here. I'll try Google. So, still no good pictures. Waterfall's kind of this process, right, where you come through and you design this stuff, and then you release it. Like you do everything, you get everything designed, and then you move on to the next thing. But that's bloody ridiculous, because how can you expect to get every single thing perfectly defined and ready and in the headspace and everyone's on the same page, and then move into the next thing? That's just impossible. Because as soon as you start doing something, instantly something is going to come up. Instantly, there's going to be a bug with the new software project, the new library that we're going to use. We have to deprecate it and we have to move on to the new version. Or the design that we came up with, actually, when we tested it with the users, they hated it and it was ugly, and we had to go and rethink everything. Or there's so many things that come out down the bottom of the waterfall, right? There's so much chaos involved that it's almost impossible to define the perfect steps to go down. Right? This is very wonderful in theory, but in reality, it doesn't work like this. So there's this concept called agile, which is you try to get to this process where you're releasing something and you're testing it as quickly as possible. Right? You're forgetting this, you're scrapping this idea, and you're saying, let's get something out there as quickly as possible and test it. Does it work? Does it not work? What does work? Right? For the things that does work, right, let's focus on that. For the things that don't work, let's either change them, remove them, transform them into something else. And you're going through this process as quickly as possible. Right? For those who have studied business, this is called the lean startup method. Right? So there's this process of build, measure, learn. Right? You're trying to, this is at more of like a business level, right? You're trying to do the same thing. You build a product, right? Then you go out there and you measure it. You get some real feedback from this, and then you learn from that. And then you take those learnings and you turn that into your next development cycle. So that is a process that has become extremely popular with startups and even large businesses now. Internally, teams are working through this process. Agile, Scrum, it's all this process of lean, building things quickly and forgetting about this massive design process and UML diagrams. And now, that said, right, this is for code mentoring. We're using this database diagram for, I know this is not exactly for classes, but it's very analogous to the database diagrams that we're building for Project CM. This is useful as reference, right? But and a little bit of planning here and there. But I'm not going through every one of my classes and doing UMLs, because if I did that, right, nothing would get done. So as a developer, as a programmer that's worth your weight, right, worth your salt, worth the money that your companies are paying for you, you have to be dynamic. You have to be flexible. And you have to say, look, I understand that not everything is going to be defined straight away. Okay? I'm flexible. I'm going to come along and work with people to, yes, try and define as much as possible up front, but then let's just go ahead and jump in and do it. And it's striking the balance between these two things. right? I have a lot of experience as a tech lead, and when I have developers come to me and say, hey, can I get a huge specification document before I start working? I go, look, that's not helpful. Right? That actually doesn't help the project. I would much prefer if you jump in and you try to start doing some of these things. We can have a high level discussion about, what are the business requirements, but even they're not defined. Right? You're working in startups, you're working in a lot of these things. Even the business, even the product management team, the designers, even they don't have everything specified. So, you gotta make do. You gotta be flexible and constantly be shifting and changing and adapting as you move forwards, because that's what life is about. Nothing in life is static. So I know that was a bit of a rant, a bit of a tangent, but hopefully that was useful.
Tristan, I don't know if he meant if there's a way to document, like if any of these IDEs do it for you. I'm not sure if that's what he meant. I don't know who asked the question, but
I think it was Kang. There are tools for documentation. So if you look up, say, like JS, or rather TypeScript, documentation generator, right? This will do that for you. So the idea behind this stuff is it actually generates documentation, like API. So all this stuff here, right? This is all automatically generated, and you can theme it and you can change it and whatnot. But this all comes, and there's also for JavaScript as well. So if you use but it's better with TypeScript, because TypeScript has more inference, because everything you've explicitly said, this is a string, this is a person prototype, this is a whatever, right? So TypeScript has ways of, like, there are libraries out there to generate all this stuff for you. This is very useful as a team. If you have some sort of documentation generator, this is really all you need, I would argue. Another thing as well, on a slight tangent, but around this process of how do I know what things are, is have a look at the tutorial I did around GraphQL. Specifically around GraphQL versus REST. So GraphQL is an incredible interface, or a revolution in how we think about extracting data and working with data from different separated systems, because it's typed, heavily typed. So that is another example of, and that actually generates documents for you. So for example, I'm actually just going to spin this up quickly, if you don't mind. All right, hopefully it's in a good state. So this is the project CM that we're working on as a team. I'm just going to go into the API and run that. I'll show you exactly what I mean, because it's kind of similar to UML. So start the database. Oh, I don't have Docker up and running. All right, that'll take a second to start, but that is another example, and they are very heavily linked to, say, all the, let's say we have an entity, the user entity, right? So this is defining what this is going to look like, both in the code, in the database, and in the front end and the API. Everything gets defined in one spot. So that is a really, really powerful way of defining things. And it's dynamic. Right? UML is kind of like this abstract thing that was built in the 90s that lots of university lecturers wrote books on that no one really uses. And maybe I'm wrong. Maybe that's a bit cynical or rude to say, but I find that this is useful because while you're defining the structure, you're also using the structure. So you're not wasting time messing around with stuff, right? And you can also use it in your code. Now you might say, oh, but there's generators for UML to generate my classes and things like that. It's like, yeah, well, why not just use it? Why not just start writing code that defines what it's going to look like. Like for me, this is quite easy to read, personally. I look at this and I go, cool, ID is a string, it's a field, right? Take a more complex example, like a path, right? So we've got an ID, it's a field, so field relates to, it's a GraphQL entity, GraphQL field. So this is something I can expect to use on the client, right? It's also a database field. So it's a UUID, right? We've got database columns. We've got created at columns. Like this, like joins, things like this. Like this is a really, really nice way of looking at our code and going, I know what this is going to do, right? And it's all auto-completed. So when we're using this stuff inside, say path, what's a good one? Client, say path list, right? These types are automatically imported from our API, and we have access to them. So I come in here and I can go, where is it? As path, right? And I can go path name, type name somewhere. Yeah, name. Right, we're using the names, path name. Right? We're looping over the paths. So this is all heavily typed. Now, if that's defined in UML, like, what's the point? Like, I know what this stuff is. Right? This is telling me that this stuff is a string or whatnot. And if I go into the actual code that's generated for this, like the editor for GraphQL, right? Look at this. Look at the schema that it generates. Look at all this. This is all generated automatically from the code that we wrote. So rather than going from UML to code, I would much rather go from code to UML or schema or whatever. Look at all this stuff here, right? And we've got documentation for it, which you can actually add plain English to as well if you want to like really add specifics, like ID, right? The ID string represents this. Like, let's say we go to something that's a little bit confusing. I know I'm on a little bit of a tangent here, but I thought I'd answer it because this really does tie into object-orientated programming and types and like a lot of the concepts that we've covered here today. So hopefully that answers your question. I know that was a long-winded answer, but I know there's a few people here that are learning GraphQL, and I just wanted to tie that back into what we're doing today. Cool. So any questions on anything that was covered around why I don't like UML or anything like that as a generative process?
Well, I think it's really used to just create the pathway, to be not a strict guide, but just something that says, okay, this is what we're doing. Because sometimes if you leave it up to the developers themselves, you know, they're creating, and I'm speaking generally here, not just JavaScript, they're creating variables that where it doesn't need to be created. They're creating classes where it doesn't need to be created. So I think it's a lot of times they'll do the design aspect of it first to say, okay, this is essentially what we're looking for.
Yeah.
So that there's a logical way of it, because every programmer designs differently in their head. Everybody has a shortcut way of where they think is the best way, but not necessarily everybody's going to read it or understand it that way.
Absolutely. And I think it really comes down to your level of seniority and experience. So how much experience do you have creating classes that were wrong, creating properties that were wrong? What kind of patterns have you followed and studied? What's the patterns that your work follows? Do they even have a pattern? So there's lots of little considerations like this, and yeah, sometimes like for myself, I'm good. Like I'll just jump in and start doing something. But if it's someone more junior, I might hold their hand a little bit and say, hey, like, what do we think is necessary for this? A lot of other discussions I have with, for those who know Kim, Kim and I have a lot of discussions around what things should be required. Other times not. Other times people just jump in straight away. So it really comes down to your comfortability with chaos and uncertainty, I would say. Yeah. So I think I'm going to kind of wrap it up here. So we've covered a lot of. Oh no, getters and setters. That was one extra thing. That's not really object orientated per se. I suppose it is a little bit. It's a pretty simple one. Let's have a look. So let's call them accesses. Right. So let's say we have a class person. Okay. So we know we can do things like name equals Bob Marley. Right. We can come in, we can go const Bob equals new person. All right, we can go log Bob dot name. So we know that we can do this. There shouldn't really be any questions at this point on that. But what is a getter and a setter? How is it different to this? Anybody know?
So the programmer would have to know what the values are ahead of time.
Well, either way, they're going to have to know what the values are ahead of time. Oh, you mean here? Well, not necessarily. Like you might change the name. Bob dot name equals Bruce Lee. This is no longer going to return Bob Marley. So you don't have to.
I mean, like if you want user interaction with it, if it's a free response.
Sorry, you just cut out for a sec. Can you repeat that, please?
No, I'm saying if you wanted user interaction with it, if you wanted the input, if you wanted to get something from the user, you could use it that way as well.
I don't quite understand what you mean by that. So I suppose what I was trying to get to was, what if we wanted to do something when this changes? Right. So instead of when the name changes like this, right? Maybe we should let the government know. So class government, right? And let's say it has some people, right? Or let's just say notify. I forget how it handles it internally, because no one knows how the government works really. But let's say notify name change, or legally change name. Right. From to. Okay. So and this will do something, right? So log legally changed to. Right. So how do we do this automatically when this happens? So instead of coming in here and going const gov equals new government. So instead of coming in here and saying, all right, so my name was Bob Marley, but now it's Bruce Lee. So we go government dot legally change name, all right, Bob Marley. All right, we're changing it to Bruce Lee. Right. That's terrible. There's so much room for error here, isn't there? This is actually what happens in real life. Like people, because we don't use technology and there's so much repeated information. Right? This getter and setter is actually quite analogous for how technology has changed people's lives. So to get a little bit meta. So how do we fix this? How do we fix this problem? Right? What if I accidentally type a typo in here? Right. Well, now there's I'm legally called Bruce Lees, right? But I refer to myself as Bruce Lee. Right, what if it's something else? What if we I was going to type Bood Marley, but it's terrible. What if it's Bob Marl? Right? They accidentally forget to add the EY, and they go and end changing someone else's name. That's not good. We don't want this. Right? That's a real problem. So how do we fix this? Does anybody have any ideas? And it's around the getter and setter, but I want to know if anyone here is aware of how to fix this before I show you. No one? Okay, so let's try something. I'm going to introduce two new keywords. We have get and we have set. Okay, so let's say get name. Return. So we're doing the same thing like this. Return Bob Marley. Now I'm going to turn off all the other stuff that we have, reduce it back down to the first example. Okay. So comment out the government. Now if we just go node accesses, right, it says Bob Marley because we're getting the name and it's returning Bob Marley. This is exactly the same as what we had before. These are the exact same thing. Right, there's no distinction between this and this so far. But that is only because we're getting it. How do we set it? How do we update this? If we have a set name, and that actually takes a value, so the new name. And what are we going to do with this? Does anybody have any ideas on what we can do? How do we update this? Because we're always returning Bob Marley. So what do we do here?
So have like a variable?
Two people just spoke then. I think it was Shane and Rajat. Shane, you want to go first?
Yeah, sure. Create a property for name.
Yep. And Rajat, what did you say?
Yeah, I was gonna say the same thing.
Same thing. Yep.
Yeah.
So and let's create a private property. So we'll say name, right? And we'll say return this dot name. So we're enabling public access to this private variable. And then in here, we can go this dot name equals new name. So this should hopefully work. Right? And let's also create a little constructor for it. So we can create it. So constructor. Right. This name equals name. Right. So let's say he starts off at birth. His parents call him Bob Marley. Right. So this works as expected. Then we change his name to Bruce Lee. So now it says Bruce Lee, which is great. That's what we want. That's what we would expect. So what we've just done in here, I'm going to put these on. Actually, that's a bit confusing. I'll bring this down here. Right. So what we've done, all of this code does the same thing as just saying name equals Bruce Lee or Bob Marley. Right, it's the same thing. Why did we do this? Why do we go to all this trouble? Well, if we remember, it's because we have this issue with the government where we don't want to call this. We don't want to actually call this function outside of it. Right? When we change the name like this, we want it to happen automatically. So what can we do about this? Does anybody have any ideas on what we can do about this? I want you to. I'm actually not going to continue until someone gives an answer. I want you guys to think about this.
Tristan, can you repeat it again? Question?
Yeah. So this here, where we're legally changing our name, how do we get this to happen automatically? So that when we change the name here, we don't have to do this. Because remember, as we discussed, we could potentially introduce an error in this. See how we're duplicating this information? So what can we do so that as soon as I change my name, it automatically registers that with the government? Legally change name. What can we do here?
Inherit?
No, we don't need to inherit. It's the reason why we added the getters and setters. It's the whole reason why we added this. The reason why we're not using this anymore.
Set name.
Set name. What are we gonna do here?
We call the legally change name method in set.
Yeah. Sounds like a good idea, doesn't it? Right. So legally change name. So I think we should probably use the current one. So this name. So there's no room for error. And then in the same case here, we're going to pass in the new name. So now we've completely removed any chance of error because we're not referencing things specifically. So now, whenever I call my name and I update it, it's automatically going to run this function. Automatically. Let's have a look at this. All right. Legally changed from to. Let's have a look. So we haven't instantiated the government yet. So let's go ahead and we added it down here. So why don't we for the person, why don't we register them in a government? So we'll pass it in the constructor. Right, we'll say this.government equals government. Okay. And then in the set, instead of calling gov, we'll say this.gov.legally change name. So in my own government that I belong to, whenever I update my name, I want it to automatically register that with the government. Right. So we're getting another issue here. Maybe we can't access. Well, there you go. I didn't know that. You can't access private variables in getters and setters. There you go. So legally changed name from Bob Marley to Bruce Lee. And this will happen anytime we say equals. That's what a setter does, is it calls it on the equals. What about the name, right? Let's say, whoops, log getting name. Anytime we make a reference to name when we're not assigning it, in this case here, this function gets called. So that is the distinction between a plain old property and a getter and a setter. It allows us to very specifically tell the class what to do, right, when we update something. Now, typically, you will also have to have some kind of value where you're holding the property. Because you're returning, you have to return something. You have to update something. So to create a relationship between the setter and the getter, you will often create, not always, you will often create a variable that, a private variable that will allow you to communicate between the two of them. So that was a bit of a deep dive into that, Frank. Hopefully that was helpful. Does anybody have any questions on how getters and setters work inside objects?
So, Christian, we have to pass government as well, right?
Yeah.
To the Bob or new person.
Yep. Right here.
Because like before, you was just trying to do like a government.legally change.
Yep.
That's not going to work. Okay.
It's not going to work because government legally change, it hasn't been instantiated.
Yeah. Thanks.
No worries. In well, I'm actually we can technically. So we can actually use a static method. So a static method means, so in here, let's use a different one. I don't know, static. I can't think of a good example. Maybe foo. I'm just gonna create something simple. So sorry, the story is not very good here. All right, log bar. So in this case, now we can go government dot legally change name, because that is a method. Legally change name is a method of this class. All right, so on the instance, we can go gov.legally change name. That's fine, that works. A static method allows you to go government, not the instance. Very important, not the instance. The actual blueprint itself. And we can go government dot, right, foo. Very, very different to gov.changename. This one is the instance, and this one is the static. We call this a static method. It's the same with properties. You can have static properties. So you can have a static lorem equals ipsum. Right. So I can come down and go log government dot lorem. Both of these, foo and lorem, are what we call static properties. So in this case, the first one, it's a static method. And the second one, it's a static property. And yes, static methods can also access the static properties. So I can come in here and go bar this dot lorem. Now this, in a static instance, this does not refer to the instance. It refers to the blueprint. If I was to use this here, this dot, this refers to the instance because this is not a static class. And I also can't, so I can't go this dot lorem. I don't have access to this anymore. Right, because inside here we've instantiated it. The way we can access this is this dot prototype dot lorem. I'm pretty sure that works. But you don't need to know that. That's some fancy stuff. So that's the distinction between a static and a legally, say a standard. So hopefully that helps with understanding how these things work. Just make sure it runs. Yeah, everything works fine. So, any questions on getters, setters, static, how we're passing objects in through constructors?
So in the class, I see here's the person class, you use the golf. So the golf here, you get from the outside a constant golf for new government, right?
Say that last part, from the gov we what?
In the person, we have a golf, but we didn't define that in the person. We instantiate that outside, like constant golf equal to new government.
Yeah, we passed it outside, right? Because you might have, say, Canada, right? And then you might have, say, I don't know, Ukraine. Right? And then let's just say this person that we're creating, Bob Marley, belongs to Canada. Does that answer your question?
So what's a golf here? This means in the person. In the person? The constructor here.
Yep. So what we're saying is when we create it, when we create a person, we say we assign them to a government.
So we don't need to define it in the body of the person. We just define it in the constructor directly.
Yep. Just in the constructor. Oh, you're asking, what about this? Are you saying like, is that what you mean?
Yeah.
Yeah. Okay.
Yeah,
sorry.
yeah, that's what I mean.
Technically, yes, you are correct. I should be doing this.
Oh, okay.
You don't have to.
It's still, yeah, I don't have to.
Yeah. In TypeScript, it will complain if you don't do this. It'll complain here and it'll say this.gov is not a property of class person. So you have to define it and say like in here in TypeScript you'd actually type it as a government like this, and then here you'd say name string and government. That's what you'd do for TypeScript.
Okay. Yeah. That's my questions. Okay, I got you.
Great. Any other questions on anything we've just covered? On getters, on setters, we've covered a lot of ground today. So hopefully today was useful. Let's do a recap of everything. Where did we start? I think we started in class. Yeah, we started here. So we learned about JavaScript object notation, right? JSON. So we learned that this is an instance and it's not a blueprint. We learned about the differences between the blueprints and the instances. Right? And again, you guys can stop me at any point any of this is confusing or you have questions. We learned about properties of classes and how we can define them. We learned about private properties with the hashtag or the pound symbol. We learned to effectively create a blueprint and turn a blueprint into an object. Remember the architect, engineer, builder metaphor? So as Josh pointed out, we have a function It gets called whenever we instantiate a blueprint, going from a blueprint into an instance. We learned about overloading and the patterns that we can use in overloading. We learned about doc strings. For those who don't know, you can actually document this stuff. So if I go down here and I go cn tower.authenticate, it'll actually give me, in VS Code, it will give me some documentation. And also if we use JSDoc or TSDoc, it will take this stuff and turn it into the documentation that we saw here. So that's how this is generated. Right. What else did we learn? We learned about you can have different instances of the same blueprint. In this case, we've got 3 towers: Empire State, CN, Space Needle. Right. Examples here of how we're overloading them. We learned that we can loop over these things and generate hundreds, thousands, unlimited types of objects. Right. So that was there. We learned about modules and how modules can be imported from each other. So try and open this up in the second part there. Yep. So we learned about private variables, or any functions really. Functions not shared. Right? This only lives inside this file. And then when we export something, we can have 2 types of exports. We have a named export, like here, dot building. So in this case, we're specifically accessing this. And then we also have the default export, right, in this case here. So was there any questions on modules or how these guys work together?
Will you repeat it?
Can I repeat all of what I just said?
Yeah, just about the modules.
Okay, yeah, sure. So this stuff is not shared. Anything that doesn't have the module exports.
Yeah.
Right. We can have the named exports like this. So we're dot building. Right. Module 1 dot building. Module exports dot building. And we also have the default export. So module exports equals, right? And then that gets called like this. So that's how these 2 relate. So I'm just importing that directly.
Okay.
And remember, if you pass in a relative or an absolute path, Node.js will look for the file on your system. If you don't, if you just pass it in as this, it will look for it in the Node modules folder. Big difference.
Okay.
What else did we look at? We looked at TypeScript and how you guys are starting to see how, as we start to get pretty complex, how some of these classes and whatnot will really benefit from having strong typed, for example here, right, these errors, these very strongly typed feedback systems, type indicators. We learned about getters and setters and how that is different to this, right? We learned that we only really need to use a getter and a setter when we want to dynamically do something upon setting it or retrieving that information. Right? So whenever we access it, it calls the get. Whenever we assign it, it calls the set. So we learned about that. We learned about static methods and static properties and how they apply only to the blueprint, not to the instance, and how they don't have access between each other. The static methods cannot access the instance methods, and the instance methods cannot directly, they can through the prototype, they cannot directly access the static properties. So there's some distinction there. We learned about constructors, passing things into constructors. And that's, we learned about GraphQL and why we want to use that. We learned about Agile versus Waterfall. We covered a lot of ground today, team. Covered a lot of ground. So I'd say that's pretty much a wrap. Does anybody have any questions or anything about anything that we've covered today? Could be there's no stupid questions. Is anyone confused about any little aspect of what we covered, or wants something clarified, or curious about something, wants to share something?
Tristan?
Yeah, mate.
Yeah, so basically for most of the web applications, right, especially front-end, JavaScript frameworks are used a lot these days.
Yes.
But under what situation you actually use, this object-oriented JavaScript?
All the time. Node.js.
Yes. Okay.
Node.js, I use it, for example, if you're using web components, for those who have done my web components tutorial, so you might have class fancy button extends, right, HTML element, right? Then you have like the connected callback, right? So this here is an overload extended. So the connected callback is automatically added on the HTML element. So whenever your element is put onto the page, right? So you might call super.connectedCallback to make sure it doesn't break anything. And then you might do something else like alert, right? Button was added to the page, right? So we use this stuff all the time. Everything is built on this. Now, this is not specific to JavaScript. All the stuff we covered today, all the principles of object-oriented, minus a few things around scope. Oh, that's the other thing we did today, scope. Most of this applies to pretty much every programming language there is. It's also the reason why CSS and HTML are not programming languages. They're markup languages, HTML specifically. CSS is I don't know what the technical term for it is. Style language?
Scripting language.
Say again?
I think it's just a scripting language.
Scripting language. But it's not scripting because you're not writing scripts. Scripting implies that it has some sort of logical flow that you're manipulating things, whereas CSS, you're just defining stuff. So JavaScript would be considered a scripting language. Right? So this stuff applies to so many different areas, and your knowledge and your experience in working with this stuff will translate to other languages. So if you're coming from a Java background, hopefully this tutorial was useful for you to translate some of the concepts that you know in Java over to JavaScript. So yeah, I would say officially that kind of concludes today's webinar. Thanks for watching for those on YouTube. As always, we like to stick around and be social so you guys can